These are just a couple examples of graphing piecewise functions. So starting with function g right here, you can see that g will map to three different outputs there depending on domain restrictions. So if you think about the domain restrictions kind of first of all right here, only when x is less than or equal to -3. So from here and below on the x-axis is where we're going to have the 4/3 x minus 2 equal to y. And then the next part that we have right here is between -3, excluding it though, all the way up to 4. That's going to be where we have 2 minus x equals y. And then finally, between 4 and 7 exclusive. So from there to there is where we're going to have that last part where y equals 3. So if we start with the first part right here, you just really got to think like this is just y equals 4/3 x minus 2. So graph it like you normally would, and then just we'll only have the part of it that's going to have x be a value equal to -3 or below. So to graph 4/3 x minus 2, you just start at -2 for your y-intercept, and then you're going to have a slope of 4/3. So that would go up 4 and over 3 and up 4 over 3. But going in that direction really isn't useful because we know that we want to restrict the domain to be, -3 and below. So if I keep going backwards, like that right there would be where x is -3, and then I'll kind of make one more dot. So really, this right here, and then having an arrow going forever that way, and then emphasizing that that right there has to be a filled-in dot, that's going to be kind of the first piece of this piecewise function. So the second piece is going to be the y equals 2 minus x part, which would be having a positive y-intercept of 2, but then a negative slope of -1. So it's going to look like this. We want this to go between -3 and +4 for x. So it's going to go like that. Now I guess I'm going to need an open circle there, though, because -3 is not in the domain, but 4 is in the domain for this piece. So on the other end there, I'd have a filled-in circle. So that gives you the second piece. And then the last piece of this is y equals 3 when x is between 4 and 7. So y equals 3 is just a horizontal line, the height of 3. So it'll go between those couple dots, although I should make them open circles, though, because 4 and 7 are not in the domain there. And then that would be kind of your horizontal piece. So I'm going to kind of erase some stuff because it's really just part of our scratch work. So erasing the stuff from the x-axis and those other dots. So that right there would give you the completed function defined there for that piecewise function. And then just for another example, this is the function h of x. So we'll see that for the first domain restriction, we've got between -10, including that, but excluding the -6. And then we also have a domain restriction between -6 and -2. So between there, and then we're also going to have between -2 and 0. And then finally, when x is greater than 5. So kind of a little bit of gap there, but that's okay. It'll still be a function. Because each input will go to exactly one output. So yeah, with the first one, it's just y equals -1/5 x plus 3. So if we graph that, that's going to start at +3 for a y-intercept, and then it has a negative slope of 1/5. So it'll go like this, with that -1/5 slope. We want to restrict this so that it's only between -10 and -6. So definitely like right there, we can definitely start this, and it's going to keep going. But as soon as we hit -6, it's going to have to stop. So it doesn't necessarily hit like an integer coordinate, which is fine. It kind of stops at a decimal. And -6 is not in the domain, so right there where it stopped, we're going to have an open circle right there. And then we also have the second piece of this, which is y equals x plus 2, which has a y-intercept at 2 and then a positive slope of 1. And so I'm going to have to go backwards with this one to make sure that we get it between -6 and -2 for the domain. So it looks like we're going to get that little segment right there, and then we'll have to fill in the dot there, and then the other piece of that will be a open circle. And then the next component is going to be the y equals 3x minus 5, which is between -2 and 0 for x. So to graph 3x minus 5, we're going to need a -5 y-intercept, and then a positive slope of 3, like you're seeing here. But I guess we need this between only -2 and 0. So right there, till we get to including 0. So it just seems between those couple of dots right there is when it's going to be between -2 and 0. So these other dots, I can erase those. All right, and then finally, we have that y is going to equal x when x is greater than 5. So that would be starting at 0, but then a positive slope of 1. So if I kind of follow that up, we're going to have to start right there and then go like this forever. So everything's graphed as we need it, so it's just a matter of kind of just erasing all of this scratch work right here so that we can just see the function as it was defined.